any point on the number line can represent the number 0. And if we go towards right, number 1 will, then number 2 comes up, number 3, number 4. How many numbers do you think can be there? As you know, a line extends infinitely in both directions, so there can be infinitely many numbers. We will not write all, we cannot write all either. So the number line, as we see, represents a large number of numbers, right? Now, the natural numbers, first group of numbers or collection of number, we represent by natural number n, and this is the collection of these numbers which comes naturally when we start counting, right? And how do we count objects? 1, 2, 3, 4, 5. Like how many students in your class will start counting 1, 2, 3, 4. So these are the numbers which comes in the number line also, 5, and they will continue infinitely. So this collection of number is called natural numbers. After natural numbers comes whole numbers. So whole numbers will include this 0 as well. Okay, so if we include the number 0 here, we can say that is the collection of number which represent whole number. We represent whole number by W, and which will be all those natural numbers plus one more 0 we can add here. So in our collection of natural numbers, we added 0, we get whole numbers, right? So we can say whole number is even bigger collection of numbers. Now after whole numbers comes integers. So what are integers? As we see, our numbers, this number line is extending in both direction. So we can extend this counting in the left direction, and we call these numbers -1, -2, -3, -4, and so on. As you see, this negative number can also extend in this direction infinitely. So we have infinitely many negative numbers also. Integers we represent by capital letter Z, and they include all the negative numbers. So just to show, we start from -3, -2, -1, then 0, 1, 2, 3, and we continue till infinity. So this is also as a collection of infinite numbers in both direction of the number line. Okay, so these are integers. Now after integers comes rational numbers. So what is a rational number? So it's very clear. We started with natural numbers. The natural numbers were collection of these numbers 1, 2, 3, 4. So these were the natural numbers, and these all numbers. Then we included 0 also in this. We said these are whole numbers. Then when we included the negative numbers also, both positive, negative, including 0, we said that is integer. We have written here. Next comes rational number. So what is a rational number? Rational number we represent by a letter Q. Rational numbers are represented by letter Q. Now what are they? The definition of rational number says a number that can be represented in the form of P by Q, where P and Q are integers, and one condition that Q should not be 0. Okay, why do we say Q should not be 0? Because if Q becomes 0, division by 0 is not defined. You get an undefined number. So for that reason, we avoid and we take this precaution that Q is not 0. All right. Now we will check whether the natural numbers are rational number. Let us take any of these natural numbers. Consider a natural number, say 5. Okay, 5 is a natural numbers. Is it a rational numbers? Yes, it is. Why? Because 5 can be written as 5 by 1. So it is in the form of P by Q, where P is 5 and q is 1. Of course, q is not 0, so this is a rational number. 5 is a rational number. Okay, just like that, can we say, what can we say about 0? Is 0 a rational number? Look, 0 can be written as 0 by 1. Again, this is in the form of p by q, where p is 0 and q is 1. So this is 0 is also a rational number. Now, what can you say about negative integers? Consider -2. Is -2 a rational number? Yes, -2 is a rational number because -2 can be written as -2 by 1. And that is also in the form of p by q, where p is -2 and q is 1. So what we can say that all the integers, whether they are negative, positive, or 0, they are also a rational number. So from this discussion, can we say that these are the only rational numbers possible? Hold on, we can have more. Let's see the number line once again. And let's say here is the number 0 and there is a number 1, and this, like this number line extends infinitely. 1, 2, somewhere here, 3, and so on. Okay, between 0 and 1, exactly at the center of 0 and 1, we'll have a number half. 1 by 2, half will be at the center of this, right? So also, if we again half this distance, you'll get a number on the number line which would be 1/4. Now look at these number, 1 by 2 and 1 by 4. 1 by 2 was not a member in neither it belonged to natural numbers, nor it is whole number, nor it is integer. So 1 by 2 is a different type. It's a fraction, right? It's a number that lie between 0 and 1. But one more thing about 1 by 2, 1 by 2 can be written as 2 by 4 also, right? This can be written as 3 by 6, can be written as 50 by 100, right? It can be written as, say, 48 divided by double of 48 is 96. Okay, so you can see these are called equivalent fractions. They are of course rational number because they can be written in the form of p by q. So this is what we call equivalent rational number. A number in the form of p by q can be written in different forms in equivalent. Every or any of these number will have the same meaning, 1 by 2, 2 into 1. So 2 is a prime number. Similarly, 3 is a prime number, 3 into 1. 4 is not, because 4 can be written as 2 into 2, right? 5 is a prime number, right? Likewise, we can go on. 7 is prime number. Only factor of 7 are 7 into 1, right? The next prime is not 9, 11. 11, which can be written 11 into 1. You see, in all these numbers, we have just one factor, right? 13 is also a prime number because it can be written as 13 into 1. But here we are using the term coprime. What is the meaning of coprime? Coprime means we'll consider two numbers and we make sure that they do not have any common factor. For example, 2 and 3, they are coprime. You can also say 3 and 4 are also coprime because there is no common factor other than 1. That means if you will take HCF, highest common factor of these numbers, you'll get 1. Okay. So with this definition, you can also say 9 and 10 are coprime. Are they? Even 99 and 100 are coprime. Yes, because they do not have any other common factor than 1. So there are many pair of coprimes. Okay, so whenever we want to represent a unique rational number in the form of p by q, so we make sure that p and q are integers, q is not 0, and p and q are coprime. Okay, so that should be our primary aim, to represent a unique rational number. I think we are very clear about rational number now. So let's take a question. Find 10 rational numbers between 1 and 2 to visualize and find as well. Now look here, the number line, we have a number 0 somewhere, then we have a number 1, number 2. So we want to find certain numbers between 1 and 2. For here they say 10 numbers, okay? So 1 and 2, 1 and 2, it has the same meaning. We learn about the equivalent fraction, no? In that section, we have equivalent numbers. Let me turn this into fraction first. 1 can be written as 1 by 1 and 2 can be written as 2 by 1. Okay, between these two numbers. Between 1 and 2 means between 1 by 1 and 2 by 1. Now, this means we want to find, because we want to find 10 number, can we multiply both the numbers by, say, 11? One more than the number needed. We needed 10 numbers, so we're multiplying by 11. So can I write 1 as 1 into 11 by 1 into 11, and the other number is 2 into 11 by 1 into 11. That means we need to find numbers between 11 by 11, this implies, okay, 11 by 11 and 22 by 11. Now, is it easy to find those numbers? As you see, the denominator is same, therefore the required numbers are, therefore required numbers, there will be 11 by, sorry, this is the after 11, you have the next number is 12 by 11, 13 by 11, and you go on 14 by 11, 15 by 11, 16 by 11, right? How many number? 11, and let me write here 17, 18, 19 by 11, 20 by 11, and 21 by 11. Is that right? Did we get the 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we found 10 numbers between 1 and 2. Now, natural question arises, how many numbers are there between 1 and 2? Well, we have found 10 number. Just visualize if I would have taken this as, maybe I would have multiplied this by 110, 110. Again, we get the equivalent fraction. How many numbers you see here now? So it's this number would be 110 by 111 into 110, and then this number would be 220 by 110. Now see, the denominator is 110, 220, 110. So 111 onward, you can find 100 numbers. Now, if you happen to multiply this by 2 zeros, you see here, just like that, then the numbers would be, how many numbers you can find now? You can find between 1100 and 2200. You know, you have found actually 1000 number. First, you found 10 number, 100 number, 1000 number. So likewise, you can actually find as many numbers as you want. That means between any two given numbers, there are infinitely many rational numbers. Okay, so we will sum up with this. There are infinitely many rational numbers between any two given rational number. So in today's lesson, we learn about natural numbers, then we learn about whole numbers, integers, and rational numbers. And also we saw that there are infinitely many rational numbers between any two given rational numbers. Hope this much concept is clear to you. Now, if you like this video and you want to see more of these, you can like, subscribe, and share. Also, you can comment in the comment box like what additional things you would like to see in upcoming videos. Thank you for watching. See you. Bye bye.